Okay, great. Hello, everybody, and welcome to training number 4 for the launch of the 2020 Stormwater Management Manual with the City of Portland. Today is going to focus on private and public facility site design and facility design. My name is Adrienne Iona. I'm the manager for the team, and I want to acknowledge the rest of the folks that worked on this update of the manual. Alice Coker, Amy Simpson, Ivy Dunlap, and Henry Stevens. The presentation today is going to be led by Ivy. They're the experts on these topics. So I think I'm just going to do this next slide and then hand it over to them. Ivy, can you switch it so I don't have to take control? Mm-hmm.
Hold on. There we go. Okay. Since we're losing Adrienne. Oh, okay. Ready, Henry, to go?
Yeah, and I just wanted to say, I think we should leave the questions until the end just because of the quantity of the material we have to get through or we have on the docket today. So just to acknowledge that today, February 4th, this is the last of our public trainings. It's about facility configurations, including private facilities and public green streets. We will be, as you know, we're recording this session and we will post it to make it available for later viewing. Let us know if you have other specific topics you like covered. I don't think we've heard from anybody on that, but that's a possibility. Okay, next. Okay, so I've got roughly the first half of the presentation. It's about private facilities, and what you're viewing here is the list of facilities for private property. It doesn't look a lot different than it did in the past. It's just a few layout differences. We've grouped rain gardens, basins, and planters under bioretention as bioretention facilities. That brings it into alignment with a lot of other jurisdictions. We've grouped filter strips, driveway center strips, and downspout extensions as dispersion facilities. It's important to note that the tree credit for stormwater management on private property is no longer available. It is still available, as Ivy will describe, for right-of-way projects. And then the only other thing of note here is that under number 5, other facilities, surface sand filters are back in our SWMM. BES will allow those on a very limited basis as an alternative to planters. Next. This section will be about UICs, and the list really hasn't changed. It includes drywells, soakage trenches, including chamber systems, and then subsurface sand filters, which we hardly ever see. Next. So one of the biggest changes for UICs is the sizing table for the simplified approach, which has been updated. The technical basis for the sizing has been completely reevaluated. So in some cases, the 2020 SWMM is going to require a slightly larger drywall than the 2016 SWMM did, but not in every case. The maximum catchment area for a single drywell is 5,000 square feet, as you can see on the table down there. Sites up to 10,000 square feet can use the table consistent with the simplified approach requirements. And for the first time, the manual is it explicitly says that you can use the sizing table for drywells for private streets. Next. There's new guidance for the performance approach for drywells. So there's new guidance about accounting for storage, about measuring the drawdown time, about sizing drywells under buildings, and for post-construction performance testing of drywells. Next. For drywells under buildings, again, the manual has much more guidance than it did previously. You have to size the system to infiltrate the 100-year storm or provide an overland escape route. We require a factor of safety to determine the design infiltration rate. You'll have to complete a post-construction performance test to confirm the design assumptions. You'll also have to provide pre-treatment, and you'll have to provide access for monitoring and maintenance. Next. Pre-construction testing for dry wells. There's new language about that in the SWM. So this is required not just for dry wells under buildings, but any dry wells not meeting the structural setback requirements. Designers may opt to do this voluntarily to confirm design assumptions or whether additional dry wells are needed. Say the design calls for 3 dry wells, but after installing the first one, a test can be done that indicates really 2 are required. So the criteria we've added after consulting with a geotechnical firm, we have a minimum test duration. We have language about specific to the different test types that are allowed, the standing head test versus a drawdown test. There's language about the safety factor that's required. And then the minimum extrapolation factor for developing an estimate for the entire dry well. So it's still a smaller test, right? A performance test of the dry well in the lower half of it likely. And there's that question about how much you can extrapolate those results to estimate the performance of the larger dry well. Next. Next, okay, thanks. For UICs, pre-treatment requirements haven't really changed, but we've grouped them together in a table that should be easier to access as far as looking at those requirements side by side. And as you probably know, for certain types of lower use surfaces like residential dry wells, we don't require stormwater facilities size to treat the water quality storm event. And no pre-treatment is required for pedestrian-only areas and roofs. On the right, that's a new detail for something that looks a lot like the sedimentation systems we use in the right-of-way. So it's a new detail for private property use. That's basically the same thing as we use in the right-of-way. And of course, we call it a sedimentation maintenance hole these days. Next. Soakage trenches, just a small change to how we size them. It used to be a length of trench per unit roof area. Now we're to provide flexibility. The sizing factor is now 25 square feet of trench, that's surface area per 500 square feet of catchment area. Next. There really aren't many changes to the UIC setback requirements. Just to confirm, setbacks are measured from the center of the dry well, unless the gravel layer that's surrounding the ring, between the ring and the soil, if that exceeds more than a foot, then the setback is to that edge of gravel. But I think most dry wells are built with 1 foot of gravel. There's no setback required along the right-of-way property line. And if setback requirements aren't met, maintenance access is required, consistent with what I described for dry wells under structures, buildings. Next. For Ecoroofs, many of the changes in the SWM this time around are due to the appearance of the Central City 2035 Ecoroof requirements a couple years ago. And the manual's been updated accordingly. So there's updated planning and zoning requirements. There's guidance for sizing Ecoroofs that cover part of the roof. There's the so-called Ecoroof exemption, which for Ecoroofs covering at least 60% of a roof, they can be exempted from infiltration testing requirements if they otherwise meet the requirements of the SWM. And now for things like roof gardens and green roof systems with more than 6 inches of media, we have new guidance for those kinds of systems. Next. For basins and planters, just a few changes to report. Swales have been moved. Bioretention swales have been removed as a separate facility type. If you want guidance on designing long, narrow basins, look for that in the basin section of the design criteria. Grassy swales, of course, still live on. They exist there in the latter half of the manual, but we realized there was way too much confusion about the very similar cross sections between swales and basins in the past, and we think just to stem the confusion, we've made bioretention swales part of the basin design criteria. And line basins have gone away under the simplified approach just because of the long history of implementation problems, where in many cases there were non-professionals who were installing liners, and just led to a number of problems during construction, but also for our permitting staff. So that's been removed. Next. Driveway center strips. Those have been broken out as a separate item in chapter 3. They used to be just part of filter strips, and they're allowed under the simplified approach under all soil types. That minimum width of the center strip is 3 feet. We do have new limits. The maximum slope along the length is 15%. And if you've got a slope of 10 to 15%, that there's a limit of 50 feet on the length. And it can be vegetated or gravel covered. We require 4 inches of gravel on that center strip. Next. Filter strips. The technical basis for the sizing tables that we have for filter strips has been completely reevaluated and reworked, and I think that the technical basis is a lot more solid. These are allowed under the simplified and performance approaches. And there are sizing tables for the performance approach within the section devoted to filter strips. So we're really hoping we've expanded the applicability, again, allowed in all soil types, and without a limit on the total impervious area managed, although there are dimension limits on the impervious area, a maximum width of 12 feet and a maximum slope of 10%. And as you can imagine, for anybody who's worked on filter strips, there's a lot of attention paid to that core principle of maintaining sheet flow both across the impervious area, draining to the filter strip, and in the filter strip itself. Next. So here's the simplified approach sizing table for filter strips, and just so you can see it, you can see that if you have a infiltration rate of greater than or equal to 2 inches per hour and you've got a slope of 10%, the new sizing ratio for the filter strip relative to the impervious area comparison of widths is 2/3. So that's slightly larger than it was previously, but again, we think the additional information is going to allow for a much broader application of this approach. There are performance approach sizing tables that address water quality and flow control as well as other options. Next. Downspout extensions. The only news here really is that BES is changing its position on these. They're really only going to be allowed as retrofits, not for new and redevelopment, because of all the trouble for design and permitting and construction that we've seen over the years with simple downspout disconnections. Next. Surface sand filters, as I mentioned, they are back in the SWMM. They're allowed under the simplified and the performance approach, but BES is going to allow them in very limited circumstances and only when the Bureau agrees that planters aren't viable. And one example where they may not be viable is in a heavily shaded setting. There may be some other instances, but again, BES has to agree to it. And you'll find those at the very end of chapter 3. Next. There are a few new details. Both of these are at the request of designers. Simplified approach details we've been asked for years for a simplified approach check dam, which is there on the left. And then on the right, people have asked for flow dissipators that you might use in any landscape facility where this is to spread flows as it enters the facility. And to help avoid bypassing along the walls, which we know sometimes occurs, and just generally better wet the soil in the facility more broadly. Next. New submittal tables. This isn't new information, but it's been put together in a easy to consult table in one place, and there are links there on the right to the appropriate SWMM section. Next, and there's a handy dandy table for additional submittal requirements that may apply, also with the links on the right there. Next. On the subject of O&M forms and O&M requirements, one of the only pieces of real news is that we have a new O&M form For shared facilities, say on a private street, the form allows for more property owners to enter their information, and it should serve both the public and BES well. And they're just minor updates to the standard O&M form otherwise. Next. Okay, I'm going to talk about the quite a few slides coming devoted to the new cross section for our standard presumptive approach designs. But this first slide, I wanted to talk first about the cross section for simplified basin and planters. There's just a couple of changes here. All simplified basins and planters continue to have underdrains, lines, and infiltration systems. And the rock layer is unchanged in the respect that it still stretches the full length and the breadth of the facility. There's been a change to the depth of the rock layer on the bottom. It's now 6 inches. It was previously 12. So that includes 4 inches of drain rock and then 2 inches of filter aggregate above that. Maybe the biggest change is that we're now requiring 24 inches of blended soil in all systems, lined and unlined under the simplified approach. It used to be 18. And that's largely to improve conditions, summertime conditions for plants as far as the reservoir of water that's held by the soil. It'll also include retention somewhat, but the priority here really was summertime plant health. Okay, next slide. So under the presumptive approach, first of all, on the left, you can see that's the cross section for infiltration facilities where the blended soil is being placed on top of native soil. And in those cases, again, for plant health, the maximum allowable depth of the imported media is 12 inches. And that's, I guess for obvious reasons, the native soil generally has better water holding capacity and fertility than the imported media. And then on the right, under the presumptive approach, but consistent with the simplified approach, all systems that have a rock gallery or drain system at the bottom, whether that's a shortened system under our new requirements, all systems with underdrains are required to import 24 inches of the blended soil. And again, that's to improve conditions for plant and somewhat improve retention characteristics. Next. Okay, so here's the new underdrain setup. I'm going to talk about the whys of it and provide more detail, but this, I wanted to just give you a sense of what it is. This is on the right there, you can see that cross section, and it's required for the presumptive approach and green streets. So we're going to see most facilities with underdrains that are designed under the presumptive or performance approach comply with this new requirement. The standard length of the underdrain assembly, including the aggregate, is a quarter of the facility length. This is what the pack will give you. So it's dramatically shorter than it was previously. The slotted underdrain, or the underdrain, is now a standard engineered slotted underdrain system. It's a standard well casing pipe that's available locally. And there is now, instead of a 2-layer rock system, it's a single aggregate that surrounds the underdrain. This is 1/4-10 washed angular aggregate. So that's mounted around that new underdrain system. Next. So why are we doing this? This is really building on the long experience of the city of Seattle. We drew heavily on their experience with this type of an underdrain system. It allows for a larger volume of soil. Back to that theme, we think it's going to provide for better plant health, expanding the rooting zone and increasing that moisture reserve, also increasing stormwater retention. Because much of the facility doesn't have a rock layer beneath it, we think it'll reduce bypass along the walls. And there should be less concern about movement of the soil into the underlying drain rock, which was an issue that surfaced a few times, not recently, but there were times in the past when BES had trouble sourcing the right filter aggregate. And we think the new 1/4-10 is going to be super helpful as far as availability and its standardization of the material. And finally, it should be easier to construct, right? It's got 1 aggregate layer instead of 2. There'll be less confusion about the specification, which we definitely were aware of on the private side. And the well screen pipe comes with those engineered slots from the factory, so there's no additional labor or confusion about the size of the drain holes or the spacing, which again, we saw most of the confusion about that was for private facilities. Next. So just to give you a visual of what this stuff looks like, on the left, you can see that standard well casing slotted PVC pipe. It was fairly easy to come up with a specification for that. More difficult was the specification for the filter aggregate. You can see we looked at a variety of materials with our materials testing lab, geotechnical folks. And this took a lot longer to decide on, but the winner was the in the container in the middle. Again, it's that 1/4-10 washed angular aggregate. And of course, the washed and angular are very important characteristics of the material. Particularly that it has to be this fractured angular material that allows for the mounding of that material and a very reduced incidence of sloughing or raveling. Next. To give you a sense of what this looks like, these photos are from the same project, this SLU Outfall 104B project that was really our main pilot project for the new underdrain approach. These were constructed a couple of years ago, and we are monitoring these facilities for various performance characteristics. But of course, during construction, the big question was whether we would have any construction problems in sourcing the material or completing the construction. And we really didn't have any problems to speak of. So the photo on the left is of the new underdrain system. You can see it's an infiltration system, right? There's no liner there, but it's got that shortened underdrain and the mounded gravel overlaying the shortened underdrain with a flat top. Again, this angular material allows for that, and the beehive standpipe at the end. And then on the right, that's the thing we've been building for many years, which has a rock gallery that extends the full length and breadth of the facility. You're looking at the surface of the choker or filter layer there. Next. Okay, so connected with the underdrains, we have a new orifice control requirements for many underdrain systems. I think a lot of you are professional designers and know what an orifice is. Anyway, it's an engineered construction that controls discharge rates, and we are among many jurisdictions that are beginning to require orifice controls to control discharge rates from these kinds of facilities. And why are we doing that? I think it's common knowledge these days. We aren't the only ones to conclude over the course of many years of monitoring that the blended soil produces mixed results when it comes to providing flow control. So the blended soil material is sensitive to a lot of things, sensitive to the composition and mixing. Is sensitive to how the material is placed and the moisture content. When the material is placed, how it's placed, is it conveyed into place? It's sensitive to sedimentation over time. It's sensitive to the weathering of the material. And of course, there's the dynamic influence of plant roots growing and dying, which we think is an integral part of the ongoing, sustaining the infiltration we need in these facilities, but it creates a lot of variability in the drawdown rates. We know the drawdown rate, infiltration varies by season, variable with temperature and the moisture content. And then of course, we have this potential for short circuiting along the root channels and along the walls, particularly when the soil block shrinks back from the walls at the end of an extended dry period. Again, we aren't the only ones who are doing this. Philadelphia in particular has a long history of success with small orifices on the end of underdrains for bioretention systems. Denver's also doing it. Gresham is doing a lot of testing, I think as retrofits on the underdrains for bioretention facilities. Wilsonville, we're seeing them in Wilsonville. And then we've had a pilot that we've been monitoring since 2016. And I just wanted to note that, as you'll see, the modifications required for the bioretention under drains, in many cases, is a simple modification if there's an overflow catch basin or structure such as the beehive that we use in our green streets. Next. So what does this look like? Here's, well, two examples anyway. On the left, those two pictures are from our pilot installation on Southeast Foster that's been in place since 2016. We haven't had any problems with clogging, and we look at it on a regular basis. The orifice is 1/2 inch on that one, and we, unlike a permanent installation, we drilled the orifice hole in a gate valve, as you can see, that would have allowed us to open it up if we had needed to, if the system had clogged, and we haven't had that problem. And then on the right, Gresham, as Tori could explain better, has had great success retrofitting some of its existing bioretention facilities. They've used wing nut test plugs, and you can see one in the bottom there. It's yellow and it's plastic. They had great success with 1/2 inch orifices in a group of retrofit facilities. And so for the last year, they had retrofit about a year ago, a bunch of facilities with 1/4 inch orifices, and had good results from those. Next. So our new minimum orifice diameters are in that first line of the table there. And this is for cases in which all of the flow is filtered. For both public and private facilities. Under the presumptive approach, the PAC will require orifice diameters as small as 3/8 of an inch. And of course, we didn't go lower than this because of concerns about potential clogging. Now, if the orifice is taking some unfiltered flow, say in larger storms for a more traditional orifice setup, the minimum diameter, the standard hasn't changed for us. It's still 2 inches for public facilities and 1 inch for private facilities. Next. So there are going to be some catchments for which a 3/8 inch orifice is too small to provide meaningful flow control. So the manual acknowledges that, and the PAC does. And so if a catchment is smaller than a certain threshold size, which there's a table for at the bottom here that's contained in an appendix, if that catchment's too small, then the facility, to make it a reasonable size, we're going to require that the design has to filter the 25-year, 24-hour norm without overflow. And that's based on the 6 inches per hour assumption for our imported soil blend. And again, the PAC will provide you with those sizings. Next. So for private facilities, the configuration for this new orifice requirement is really up to the designer. The SWM does provide some examples. There's a page, I think there are 4 examples to provide some ideas for designers. And of course, on the left here, that's directly, it's very similar to what we think we'll see a lot of in the right-of-way, where there's been a cap put on the underdrain that's been extended a little bit into the facility to allow for the cap, and then the cap has been drilled with the orifice. And then on the right is something newer. We've seen this from Omaha, Nebraska. We've also seen it from closer to home, Wilsonville, where there's a gate valve that is housed in a standpipe that makes it somewhat accessible. And the orifice is drilled in that gate valve. And so once again, it's really up to the designer. We put the burden squarely on them to come up with a design that best suits the site conditions and allows for access for maintenance and ensures the reliability of the system. Next. A couple of details for public facilities on the right. Again, continuing with the orifice, there's looking down on the underdrain pipe entering the control structure, which would be on the left. The pipe extends into the structure long enough to allow an adapter that allows a screw cap to go on the end of it. And then the orifice is drilled in the nut of that plastic screw cap. And this is the approach that's been used by Philadelphia with great success, as reported by them for many years. And then on the left, well, that's fine. On the left, that's a cross section just showing how the mounted gravel sits around that underdrain pipe from the end, showing has a limited cross section. Next. And so just to acknowledge that the Orifice is a new requirement, and I think we're looking forward to getting feedback about it, and we think we look forward to making improvements to the requirements. Look forward to hearing from designers, everybody from designers to our own maintenance inspection program as they're looking at systems on private property. Just to acknowledge that picture of me with reaching my long arm down to assess whether the orifice is clogged. It helps to have someone with a long arm. That's one of our beehive systems. That's for our test facility out on Foster. And again, the configuration and accessibility is everything, of course, in the long run. And on the lower right, that's a picture from the city of Pittsburgh that was part of a discussion about the fact that simple grout that around the pipe where the underdrain where it penetrates the beehive or the control structure, and there is an orifice on you can't see it very well in the nut of that plastic cap. There could be trouble with leakage over time as the grout degrades, and I think we may have standards in the future for seals on those systems. Okay, next. Ivy, I think it's your turn.
Okay, thank you. Let's see if I can turn my screen on. Okay, I have kind of a lot going on here. So, and my screens are set up, so I'm not gonna look at you probably as much as I should. So sorry about that, but it's just how it happened and I don't want to rock the boat. So I'm going to talk about Chapter 4, which are the design requirements for facilities that are allowed in the right-of-way. So this is a new organization, as Henry mentioned. Chapter 3 is the private facilities, and these are the right-of-way facilities. There's a new section for vegetated stormwater facilities or green streets. Previously, this was broken out into swales, planters, and curb extensions. And so we've combined these to avoid repeating information into one vegetated stormwater section. Most other things are the same. There's some slight changes to manufactured stormwater treatment technologies and to the tree credits that I will also talk about. Okay. So I'll just quickly mention that presentation 2 had information about triggers in the right-of-way in particular, and some changes to the triggers and the changes to the maintenance definition that might change your requirements in the right-of-way. I'm not going to get into that here, but just want to acknowledge that you might look into it. And we're also working on a document that will explain that in more detail and give some examples about how that will apply. So for the vegetated facility section, there's a new subsection called Guidelines for Site Design, and this includes information that PBOT and BES has been collecting and applying over the years for our best practices in horizontal design and relationships with pedestrians and curb ramps and trees and a variety of things. So I'll talk a little bit more about that. The stormwater requirements are mostly the same, except for what Henry mentioned with the underdrain. And I'll mention a couple other items. So all the stormwater requirements are bundled together now. So as far as the site design, this is a diagram showing, indicating that to be sure you line up any pedestrian markings so that you don't lead the pedestrian into a facility. So this was not intentional, but we realized with feedback that some of our facilities and the pedestrian organization was a problem for the visually impaired. So just acknowledging that and reminding everyone to think about it. Along those lines, this is another example of the actual sidewalk leading into the facility. So we have some solutions, including a railing, as you can see in the drawing. But probably preferred by the visually impaired would be to just have the shift the edge of the vegetation over so that it lined up with the facility, and didn't lead a person into the stormwater facility. We've included some guidance to think about the maintenance staff. So considering nearby parking and access for staff, and then also in median facilities to include a buffer, a maintenance buffer, to avoid situations like this along the streetcar, as you can see, where the maintenance staff end up being very, very close to the streetcar and other traffic. And then one tiny little item that we snuck in is a requirement for when you're near the corner and you have a wall, a planter wall, to make the planter wall 12 inches wide to allow for sign installation on the wall, so we don't end up with signs in the facility, which can be a problem. So one of the biggest changes that I'll spend a minute on here is changes in requirements to planting strip facilities, also known as swales, which are trying not to use swale quite as much, but sometimes I still slip up and call it a swale. So this would be a planting strip facility with side slopes. And we have found, BES has found that we have trouble with plants surviving in that high and dry area, in addition to the soil migrating down the slope and undermining the sidewalk. As you can see in the pictures, also the use of that swale and an 8-foot wide planting strip just isn't a very efficient use of the right of way for stormwater. You can see not very much of the area is actually collecting stormwater. So the changes and new requirements are to have a thickened edge sidewalk along the sloped edge, and also a 2-foot wide flat bottom whenever there are side slopes. So this, the result is that it's, to use this swale or double-sided slope configuration, you would need an 11.5-foot wide planting strip to install them. However, the option, or the idea is not to make more swales or to require more right-of-way dedication. The intention is to encourage other design solutions in that 8-foot wide planting strip. And there are 4 examples on the slide. There's the very popular swaleter on the bottom left. If you don't have parking, you can use an efficient planter with just the straight sides. So there are other options, and we really want to steer people away from that swale and side slope rather than requiring additional dedication. So for new stormwater requirements for the behind the curb facilities, for the planting strip facilities, we have some new inlet guidance. So we have 3 tables, 3 tables that help you figure out how many inlets to put along your facility. And this is based on your catchment area, your slope, and then also the design storm that you are working for or designing to. And so one result is that when your slope is 6% and above. The first inlet in the line is required to be what we're calling a really exciting concrete inlet type metal with G1 or G2 grate. And I'll show you another picture of that, this section that shows you a little bit better how the water gets into the facility. We also have a little bit more guidance for curb extensions on inlets. We don't have tables. That first inlet and curb extensions, as you can imagine, is pretty effective. But it's really when the water needs to take that 90-degree turn that we are having a little bit more guidance for inlets. So I'm going to go through the details kind of quickly and point out some of the new details and changes that we've made. We still have a SW series of details that are in the manual. These are the details that are meant to be modified by the designer. They're not intended to be cut and paste. They have guidance for how to use them. Let's see, I already talked about the swale or the side slope facility. I'll point out some new details for inlets. One is a notched 4-bay wall for planters. So this will be required on higher traffic streets or streets that generate more sediment to help with maintenance and also keep all that sediment from just overwhelming the plant material. There is a companion detail for curb extensions for the notched 4-bay wall. And then we also have included a carriage walk with trench grate detail. So this connects to bays of the facility with the carriage walk. This isn't the preferred solution, but it can be an option in some cases. And then check dams, the changes that we're not allowing the wood check dams any longer. We had problems with maintenance as well as construction. So concrete check dams are what is left. And we have added 3 new check dam details to show that relationship between the check dam and the rock. Previously, it was just kind of left up to the designer if the check dam went on top of the rock, or and also that relationship with a liner in a lined facility. So we've added more detail about that. And then Henry also showed this, just acknowledging the changes that Henry spoke about applying the right of way. For tree installation, the change there is that previously, if there was a rock gallery in a facility, we required over excavating the location where the tree was going to be placed and adding more soil. But we've changed that completely to requiring a bench of native soil where the tree will be placed so that the root ball can be placed on a sturdy native soil bench, if you will, rather than into the imported soil, just to be in better alignment with standard tree planting practices. So 15 of the details have been moved to the PBOT or City of Portland Standard Detail website. They're posted up there now. They're the 300 series. And these are the details that are meant to not change for your project. And this is meant to really help with construction, eliminate construction confusion, and also streamline maintenance in the long term. A couple of changes we've changed from the angled inlet to using the 18-inch typical metal inlet so that it comes out 90 degrees or perpendicular from the curb. On the top, you can see that metal inlet with G1 or G2 again. And you can see the really shallow catch basin, and that catch basin connects with the splash pad into the facility. So the water has two ways to get into the facility, both through the grate and then taking that 90-degree turn through the inlet. And then here's the companion detail for the curb extension with notched forebay. A little change on the 2-year maintenance warranty paperwork. We are now requiring signature on the paperwork from the person that will, or the representative that will be performing the maintenance work. We were finding that the information wasn't getting passed along to the person or the company that was actually doing the maintenance, and some things were getting dropped. So this ensures that the requirements are communicated to the correct people. So the tree credit, a couple changes here. This still applies to new and existing trees. We've removed the maximum percentage of impervious area of your project than it can manage. And this is just to be more practical and reasonable for linear projects. We've modified, given the fact that we took away the maximum percentage, we modified the calculations and just made some simple 100 square foot and 200 square foot credit categories. And then the worksheet turns out is very simple to fill out because the math is very simple now. So those are the changes on the tree credit. Henry's gonna pop back in and talk about manufactured treatment technologies.
Yeah, thanks, Ivy. So we call them MSTTs, Manufactured Stormwater Treatment Technologies. Many of you probably know these jurisdictions have different names. They're often called stormwater treatment devices. The context storm filter would be one of the examples. And so for following on Ivy's presentation for right-of-way facilities, in the right-of-way, a couple of additional requirements: size of the facility to manage the full catchment area, not just the new impervious area, which has been confusing, I think, in the past. And then BES as a fairly standard practice, typically, not always, but typically requires installation of a SED maintenance hole as pre-treatment upstream of an MSTT. And that's to increase the interval between maintenance visits. Next. And then about Portland's list of approved MSTTs, and this applies for both public and private facilities. We now have 8 approved devices, and you can see that on the right. Those are online with the conditions. You can open up and see where we allow them. I also wanted to acknowledge that we have revised the application process for vendors who want to come in and have us review and hopefully approve their device for use in the city of Portland. We've beefed up the criteria, so we're transparent about how we make decisions about what we allow and why and where, so the basis for our approvals. And then there's a brand new 2-year delay that we're requiring between the approval of the device by the state of Washington under the Washington Tape Approval Program. And that's where the vendors have to, they spend a lot of money to show that their device is capable of meeting the water quality requirements of the state of Washington. Anyway, we're now going to require a 2-year delay between the award of the Washington Tape GULD approval and application to us, to the city of Portland. And that's to address the lack of documentation concerning O&M, the O&M record of the device when it comes to us, typically just after approval by the state of Washington. The state of Washington has that standard that, for water quality performance, but there is no standard for O&M, particularly the maintenance interval that's required. And so this new 2-year delay is our attempt to get more and better information about the maintenance interval required for our decision making during the review process for new MSTTs. There seem to be plenty of these devices in the queue at the state of Washington. We expect that the list of approved devices will increase here as well. Okay.
I think that's what we have here for you today. Adrian, I believe, is monitoring the chat for questions, but you can also raise your hand. I have the participant list up. Either one is fine.
So I've got one in the chat that for Henry. We could probably stop the screen sharing. What do you think?
Oh yeah, I forgot it was on.
So Henry, Adam Stefan wants to know if the quarter 10 rock is required to be fully fractured or if it's allowed as fractured river rock. I don't know the answer to that one.
Yeah, I'm not sure about the answer either. Good question. And I have to, as we get underway with a new requirement, I need to reassess the material. That's thanks for pointing out that distinction. I've not heard that distinction before. I know it, just only that it needs to be fractured and angular.
Okay, thanks, Henry. I was just wondering also related to that, there's no geotextile then over the pipe or there's no burrito wrap?
No, we continue to allow, under the performance approach, we allow designers to use geotextile. We don't recommend it. And we don't require it on any of our facilities.
But we also don't allow it in the right of way. So private property, there might be that choice, but not in the right of way.
Okay. And the earlier question was, I would assume the river rock, if it's crushed, there's a larger void space in there. So compared to a fully angular rock from quarries. So that's kind of where the question was coming from as far as sedimentation of topsoil or planter mix fines getting into the rock and all the way to the pipe.
Yeah, the filter analysis, the traditional filter analysis that was done by our materials testing lab was for this angular material that's so common here in the Portland area. It's used for sanding roads by PBOT in the winter. And so that's the material that we used in that analysis. And
Okay.
Anyway, happy to talk more about it.
Thanks.
All right, Tom has his hand up.
Oh, Tom.
Well, do you want to go ahead and get the people that went through the trouble of typing in their chats? And
Sure, there's I only have one just showed up, so I saw
Okay.
your hand first. So Wes wants to know, let's see, if we're interested, does BES have any appetite for stormwater trees installed in large volumes of rootable soil material underneath suspended pavement, for example, silvicell, structural soils, etc. Yeah, I mean, I'd say that that's a sort of facility type and structure that we've been curious about. And I think there are a couple projects in the city where that's been done. The conversation about use for that in the right of way has not really happened. I think there's a fair amount of interest on our part and from urban forestry, but that requires conversations with a lot of different bureaus that would need to happen before something like that was implemented. But on the private side, you guys think that's I feel like that's something that could be, that has been considered and could be considered on the private side as a performance approach facility.
Yeah, and we've also been in touch with other municipalities that have been doing that sort of thing. So we are interested, but just haven't quite gotten the traction. And I think urban forestry is also interested in trying it. It's just getting the stars to align on a project. If you have one, let us know. Let's see then, Tom.
Okay, thank you. So earlier, Henry, you had mentioned that there's a post-construction test requirement, and I think that was related to dry wells. And I've always been in favor of this particular activity or requirement. And I would just make a suggestion that I think that whether you make it a part of some formalized way to do it, everybody on this presentation today to require that there's a flow test relative to curb cuts, inlets, and various other ways to make sure the water gets in. And I've even noticed at, for instance, Reed College, they have a driveway where they put in some new pavement in conjunction with some existing pavement. And because of the paving, it actually, when it's raining, the water, it deflects the water and it doesn't go toward the new inlets that they put in. And so that's one part. So I would recommend that I think you guys ought to make it a requirement, and that's, whether it's a hose or a fire hydrant or rainstorm, and it seems like they could maybe even just do a video with their cell phone that might be sufficient to do the job. But I really highly recommend that that's done, and I think we'll get a lot better work out there. Now, if something doesn't work like this pavement at Reed College, that's a major fix. And so anyway, so that's not good news for the contractor and potentially designers. But the other thing that relates to that then is I noticed in one of your slides that you have, you're showing curb cuts, and the curb cuts enter into the facility, and then you show gravel. And I think you show gravel in some of your, so instead of a concrete or some other solid pad, splash pad, you're showing this gravel. And my experience, and I just saw one the other day at Willamette Park, and it was gravel, and gravel facilitates sediment control, and sediment control facilitates seed control, and all of a sudden you get a bunch of grass and weeds growing, and the inlets are plugged. So I would actually recommend that you don't allow gravel splash pads, that you require that they be some kind of solid material like concrete or maybe some kind of thick plastic or something, because it really facilitates the growth of weeds and grasses, and they plug up faster than I think if it's a solid pad.
Mhm.
So those are my two thoughts about, or not questions, I'm sorry, I should say. What do you think of that?
Thanks, Tom.
You don't have to answer.
Yeah, I don't know if anybody, I mean, I think definitely we're aware of those fine grading issues, that post testing to make sure water gets into the facility is definitely a different kind of post testing than the dry well capacity testing that we have in there. But is not I'm not sure how it would fit in with our inspection protocols. That's probably the primary challenge with that.
Yeah, I think the inspector, Joe's group, could probably figure out how to get it done in some way. It adds another level of work for Joe's group, or the right-of-way people, or Joe's group for private property. I just think I get out there a lot. I'm retired and I'm going around town and looking at stuff, and man, there are a lot of plugged up inlets.
Yeah, no kidding. And I think, and also the new concrete forebay, I think will help with the inlet clearing situation. I don't know if we have other things. I think the gravel inlets are more on the private side, where there's
the
tends
one
to be
that
slightly less
yeah,
of a problem with that. But yeah, I think we are aware of that, and the inlets and splash pads and things have definitely moved more towards the concrete direction. Ivy and Henry, you have anything to add on that?
Well, I think in the right of way, we only allow the concrete now.
Right.
And sometimes like the forebay check notched forebay check dam thing, even more concrete.
Mhm.
I'm showing slide 42 and 43 again because there was a request in the chat to see that again. Anyway, does anyone have a specific question, or whoops, where's 42? I don't know where 42 is. But anyway, am I showing what you wanted, what your question was? And if,
Yeah, feel free to unmute and tell us if this is the right slide.
yeah,
Yeah, it seems like slide 42 doesn't exist. I just was worried. I thought I might have missed it. Thank you.
okay. That's so weird.
That is totally weird. Okay, so I have an orifice question. If the overflow beehive is directly downstream and or in line with the low flow orifice, as depicted in the picture on the right side of slide 33, is the minimum orifice size 3/8 of an inch or 1/2 inches. In other words, yeah, so how are we interpreting the filtered flow? So the filtered flow does refer only to the water upstream of the orifice. So the water that's going through the orifice has to all be filtered. You want to add to that, Henry?
No, I think that covers it. Thanks.
Okay. Yeah, the big problem, yeah, basically want all that water to have gone through the soil or some other kind of filter media before it sees that orifice. What if there is sediment laden flow directly downstream of the orifice? That's fine. We're not worried about that. Let's see.
I mean, we are worried because then that's like sediment that maybe is getting somewhere where we don't want it. But as far as for the orifice, we don't care.
Good point, Ivy.
We care about sediment everywhere.
Right? It's bad for water quality. Not okay for orifice maintenance.
Yeah.
Okay. Here's another question in the chat. If we were proposing an above ground stormwater treatment system on a private facility, where would the treatment system like that fall in the manual? We will go through the city permitting process and I don't want to miss it if it is covered in the manual. Can you maybe expound upon that? Because I think when I think about an above ground system, I'm thinking of a vegetated planter that's sort of elevated a little bit. But I think that you might be asking about something different.
Okay, can you hear me now?
Yep.
Yeah, I'm the one who asked this question. So due to the space constraints, we are proposing an above ground, meaning a treatment system that's designed by a vendor. So like tanks, adsorption filters, and like all those parts. So we will go through the city permitting process, and when I was reading the manual, I just couldn't see a section that would describe those treatment systems in the manual. And yeah, as I said, if it's in there, I don't want to miss it.
Henry, that sounds like a question for you on the MSTT front.
Yeah, Denise, maybe we could, can I connect with you by email afterwards to better understand the question? I can work through that with you.
Yeah, that would be great. I at first I thought maybe we could describe them as a manufactured technology, but when you describe manufactured technologies in here, I think those covers like contact filtration systems or small vendor filtration systems. But in our case, maybe you can chat it in the private. It's more like it's a bigger system. It's not just a catch basin filter.
Yeah, let's connect.
Okay.
I'll email you.
Okay, thank you.
Thanks. All right, I'm gonna do this one in the chat and then we're gonna go to Josh. Okay. Sherry wants to know if we have conflicts with utility stakeholders with regard to infiltration. Are there mitigation measures to make stakeholders comfortable with a reduced setback? Ivy, I feel like you're most familiar with the Water Bureau things. Why don't you take that one?
I would say that probably the conflicts with the Water Bureau are the ones that we run into the most often. Because the other utilities, we can require them to move because they're franchise utilities. I think that's what it's called. However, we do try as much as possible to work around the conflict so that we're not making people move things more than necessary. So it's a little bit of push and pull, I would say.
And also there are details in the manual for waterline crossings as they relate to green streets that have information about kind of how to manage those overlaps.
Yeah,
And sometimes, yeah, go ahead, Ivy.
Oh, I meant to mention that those are now in the standard drawings online, P331 and 332, I believe. Case.
Okay.
Yeah.
All right, Josh.
Yeah, thanks. Good presentation. I just wanted to touch on that restriction on the orifice size. You did leave in the manual that it at a discretion of the designer, you can go smaller on unfiltered flow.
Oh,
I just wanted to point that out.
Thanks for the clarification, Josh.
Not an absolute restriction, but it does, there's more responsibility with going smaller.
Yes, we forget. Sometimes I forget exactly what all is in there.
Yeah, I made sure we kept that line in there. Well, I asked to keep it in there.
Yeah, so I think we do. We do. I acknowledge that we do have that additional allowance, but I think there'll be additional scrutiny for the protection of the orifice in those situations.
Yeah, by the reviewers. I would hope for that. Yeah.
Yeah, you already have a design in the works with one of those, Josh?
Probably.
It's in for permit right now.
There you go. Okay.
Tom,
Thanks.
do you have another question, or is your hand just still up?
No, I do have another question.
Okay.
And I think Henry showed this. You were showing some cross sections of facilities, and you were talking about private property. And I think, Ivy, you even put it up there again because it might have been on 42 or something. But it shows a beehive on this private property cross section, I believe. And so, is that an option for a beehive, or is that a requirement for a beehive? It seems awfully big. An awfully big overflow facility for for many private property projects, not necessarily. There might be some big facilities. So can you find that again, Ivy? There it is. Yeah. So it says at the top, private property facilities related to the orifice stuff, and then it shows the beehive. So is that a requirement that you use a beehive, or can you do it a different way?
Tom, I can answer that. It's really up to the designer what configuration that they use that addresses the many requirements that may apply, including accessibility. So the short answer is no, the beehive is absolutely not a requirement. And we're hopeful that we're going to see over time development of some newer approaches for installing orifices. So the image on the right there is an approach we're not sure about yet, but it has been used, as I said, in Wilsonville here in Oregon, also in Omaha, where there's a gate valve with a drilled orifice in it that's housed in a standpipe. And I hope that we're going to see the development of a bunch of new approaches for smaller systems that don't require a beehive, but nonetheless allow accessibility. Okay.
And then also regarding the beehive, so as it's used, and this isn't pertaining to the orifice question, it's just in general the beehive and its use in the right of way, and specifically the right of way that's in the combined sewer area. So the combined sewer area has a lot of rats in the combined sewer, and rats use inlets as their access point to get into the combined sewer. So I'm thinking that as the beehive, this is in general, that the inlets facilitate the movement of rats back and forth from the surface streets where they're doing whatever they're doing, and then they're getting down in the sewer. So having a different kind of inlet wherever we're doing green streets would allow, if that inlet is designed so that it would restrict the rats from being able to get in or get out into the facility and then into the streets and going up into the neighborhood and that type of thing. So you'd be surprised what a retired person walking around town, even in broad daylight, sees. But if you keep your eyes open, there's a few rats out there. And I just happened to stop at an inlet one day. I heard a little squeaky noise and stopped and looked down, and all of a sudden 3 rats came running out of the inlet. And they went down the street, and I guess they were looking for food. And anyway, so there's, in the combined area especially, rats are, they live in the sewer. It's 70 degrees year round, right? So perfect environment. So anyway, just finding ways to kind of make things tougher for the rats. That's the point of this.
Yeah, that's an interesting point for future details.
Yes.
Does anybody else have any other questions about the material from today or any other things? I don't really see anything else in the chat unless I accidentally missed somebody's question from before. So yeah, feel free to raise your hand or do one more chat.
I'm going to stop the recording now.
Yeah, that's what I